So where we left off last time is that we learned that 1 mole is equal to 6.02 times 10 to the 23rd particles, right? And so I've got this Apple pencil here. I'm going to try and be able to write on these slides. 1 mole is equal to 6.02 times 10 to the 23rd, either atoms or molecules, right? And we also learned that 1 mole of a compound can contain 1 mole of individual elements. So we'll work with that a little bit as well. But we're going to do more stuff on mole calculations today. So first, we are going to talk about what molar mass is. So we know atomic mass on the periodic table, like if we look at carbon, we can see that carbon is 12.011 grams of carbon, and that is 1 mole of carbon. And we just look at that on the periodic table. But we can also do this for like compounds and things like this. So this 12.011 grams of carbon, that is called the atomic mass. We also call it the molar mass because it's the mass of 1 mole of carbon. So the molar mass is the quantity in grams that equals the atomic mass of that element. And the mass can be of 1 mole of any element or compound. So just depending on what you're looking at. This will be the mass of 6.022 times 10 to the 23rd atoms, right, which is also 1 mole. And so that can be of an element or it can be of a compound, either way. So the masses, right, like I said, on the periodic table, if you just look at like carbon, the mass of carbon is 12.01, so that would be the mass of 1 mole of carbon. But we can do this for any element, like Ag is silver. So if we look at the mass on the periodic table, it says 107.9 grams, right? And so we know that's the mass of 1 mole of silver. So whatever the mass on the periodic table, that is the mass of 1 mole of that element. So, but compounds are a little bit different. To figure out the molar mass of a compound, you'll go through and you're going to multiply the molar mass of each element by the subscript in the formula, and then we're going to round the result. So like this is NH3, right? Nitrogen trihydride. And in nitrogen trihydride, we have 1 nitrogen, right? Because this is like an imaginary 1 right here. So that's where we're getting this 1 mole of nitrogen. And then this 3 for hydrogen, right? So we have the 3 here. So these numbers that are in the front here are just telling you how many of each element is in that compound. And so the way we're going to work this out is that we're going to take that number and we're going to multiply it by the molar mass. So 1 nitrogen times the molar mass of nitrogen, and then 3 hydrogens times the molar mass of hydrogen. And so then we'll get these numbers over here to the side. So 1 times 14.01 is equal to 14.01 grams of nitrogen, and 3 times 1.01 grams of hydrogen will give us 3.03 grams of hydrogen. And then we are just going to add these. So 14.01 plus 3.03 grams will give us 17.04 grams of nitrogen trihydride, which is the molar mass of nitrogen trihydride. So if we're trying to find the molar mass of a compound, we're essentially going to add up all of the elements that are in there, all of the masses of those elements. So if we were to calculate the molar mass of a compound, so like here, this says calculate the molar mass of lithium carbonate. So what I would like you to do is go ahead and pause the recording right now and try to do this one on your own. So here's what it is, lithium carbonate, right? So I want you to try and calculate the molar mass of that compound. So go ahead and pause, and then I will go over it. Okay, so hopefully you paused and you worked through the answer on your own. So now I'm going to go ahead and give you the solution. So in this compound, we have 3 elements. We have lithium, we have carbon, and we have oxygen. Okay, so we have 2 lithiums because that subscript is a 2. We have 1 carbon, and we have 3 oxygens. So now we're going to go ahead and we are going to multiply those numbers by the molar masses of each one of those elements. So lithium has a molar mass of 6.94. And carbon has 12.01, and oxygen is 16.00. Whoops, 00. And so then when we multiply those out, sorry, let me grab my calculator. So we are getting 13.88 and 12.01, and that would be 48.00. So then we can go through and we can add these straight down. So we'll get 9, 8, we'll get a 3, carry that 1 over. So it looks like 73.89 grams per mole. So our units for these molar masses are grams per mole. Okay, so for whenever we're calculating this out. So if you have any questions here, go ahead and send them to me. Otherwise, we are going to move forward. Maybe. My slide doesn't want to advance. We'll just go ahead and skip here. So, all right, moving forward. Right now, I would go ahead and pause and work on problems 11 through 16 on your lecture worksheet, and then check your answers with the lecture worksheet key that's been posted on Canvas. So this is so that we get really good at calculating the molar masses of the elements. So like I said, I would go ahead and pause here and do that. So hopefully you've paused, you worked on problems 11 through 16, because now we're going to talk about 1 mole quantities. So if you'll look, all of these pictures are showing 1 mole of a bunch of different elements. So like the first one's 1 mole of sulfur, and then we have 1 mole of iron, 1 mole of sodium chloride, potassium dichromate, right? So we've got 1 mole of each of these. So 1 mole is going to be the mass of 6.022 times 10 to the 23rd molecules of that element or compound or whatever it is. So it has the same number of particles, right? Same number of particles, but they have different masses, right? So same number of particles, but different masses. Okay, so again, 1 mole is just telling you this is 6.022 times 10 to the 23rd particles. So that means either atoms or molecules. Okay, so again, they're going to have different masses here, but the same number of particles. So if they have different masses, right, they'll have different amounts of stuff. So that's why we're seeing all different volumes here. Go ahead and do problems 17 and 18 in your lecture worksheet. So again, go ahead and pause and then come back when you are done. So we can use the molar mass to convert between moles and grams of a substance. Kind of like last time we were using Avogadro's number to convert between moles and number of particles. Now we're going to use the molar mass to convert between grams and moles. So it can convert moles of a substance to grams, or it converts grams to moles. Either way. So this top one, this is our equality, right? And so we get this from the periodic table, and then these are going to be our conversion factors that we can use. And these will be what we can put right in our train tracks to do dimensional analysis and figure out amounts of stuff. So let's try it out. Silver metal is used in the manufacture of tableware, mirrors, dental alloys, and jewelry. If the design for a piece of jewelry requires 0.750 moles of silver, how many grams of silver are needed? So the first thing we need to do is go through and figure out our equality here. And then we can write out our conversion factors. So if we look on our periodic table, we can see that 1 mole of silver is equal to 107.9 grams of silver. So that is just from the periodic table. I looked on the periodic table, I found silver, it says 107.9 grams, so I know that the mass is 1 mole. So we can write two different conversion factors, right? We can put 1 mole of silver per 107.9 grams of silver, or we can put 107.9 grams of silver over 1 mole of silver. So then we can start our train track. So we look 0.75 moles, so that will go in the beginning of our train track. And we know, based on the way that train tracks work, right, moles has to cancel moles. So we need, if we have moles of silver up there, then we need to have moles of silver down here. So we need to find moles of silver on the bottom. So if we look, the second one appears to be the one that we need. So 1 mole of silver on the bottom, 107.9 grams of silver on the top. So we double check, moles of silver cancels moles of silver. So we do 0.750 times 107.9 divided by 1. That will get us 80.9 grams of silver. And that is our answer. So the molar mass can be used as a conversion factor in these train tracks. Go ahead and try problems 19 to 22. So pause here, try them out. So we can actually do this exact same thing, but for compounds, right? So say we needed the mass of water. So we can figure out the molar mass of water. This is 18.02. So we can write that 1 mole of water is equal to 18.02 grams of water. So we can write these two different, right? So again, this is our equality. And these two guys, these are our conversion factors. So we can use those conversion factors for compounds. Just whenever you're doing compounds, right? It's just like adding an extra step. So for elements, we can go and we can find the mass on the periodic table, but for compounds, we're going to need to go through and calculate the mass. So the mass of water here, we would go through and we would say, okay, I have, hydrogen, I have oxygen, 2 hydrogens, 1 oxygen. We would multiply that by their masses on the periodic table. And then we could add them up. So that's where that 18.02 is coming from. Okay, so it just adds in an extra step that rather than just like looking at the periodic table like we did for silver before, we would have to actually go through and calculate this number. So we can use it in these train tracks just the same. And we can, like I said, we're just going to have to calculate the molar mass of this guy along the way. So let's try it out. How many, it says a box of salt contains 737 grams of sodium chloride, and how many moles of sodium chloride are present in the box? So we can go ahead and write our equality and our conversion factors. So first thing we would need to do is figure out what's the molar mass of sodium chloride. So we have sodium, we have chlorine, we have 1 of each of them, and we can multiply that by their masses on the periodic table. Since we're multiplying by 1, these are just going to stay the same. So we can add those up, and we'll get 58.44 grams per mole. So then we can go through and we can say, okay, now we have an equality. 1 mole of sodium chloride is equal to 58.44 grams of sodium chloride. So we can write our conversion factors. 1 mole of sodium chloride over 58.44 grams of sodium chloride. Or we can put the 58.44 grams of sodium chloride on the top and 1 mole of sodium chloride on the bottom. And then we'll see which one we need. So in the problem, it says a box of salt contains 737 grams of sodium chloride. So that will go in the beginning of our train track. So then right? We know grams of sodium chloride has to cancel grams of sodium chloride and down and to the right. So we know that we're looking for grams of sodium chloride to be on the bottom. So that means we're going to use this one here on the left. So 58.44 grams of sodium chloride will go on the bottom, and 1 mole of sodium chloride will go on the top. So we make sure grams of sodium chloride cancels grams of sodium chloride. So we do 737 times 1 over 58.44, and that is getting us 12.6 moles of sodium chloride. And remember, whenever you're writing this answer, make sure you write your number, your unit, so like moles, and then your compound, which is sodium chloride. So you need all 3 of those pieces in your answer. So go ahead and try problems 23 to 26 on your lecture worksheet.